Hello everyone. In this lecture we will start a new chapter from class 10th chemistry, that is organic chemistry. So the first question comes, what is organic chemistry? Organic chemistry is the branch of chemistry which deals with the study of compounds of carbon except oxides of carbon, carbonates, bicarbonates and carbides. Now the second question comes, why do we have a separate branch, that is organic chemistry, for just to study the compounds of carbon? Why there are not so many branches for the study of compounds of different elements? It is because all the compounds that we know about, more than 90% of all known compounds are just the organic compounds or just the compounds of carbon. So therefore we have a separate branch of chemistry for organic compounds or compounds of carbon. So you can see here the hydrocarbons. So what are hydrocarbons? As you see, hydrocarbons consist of two words, hydro and carbon. So the compounds which consist of hydrogen and carbon only, obviously these are organic compounds. So the organic compounds which contain only hydrogen and carbon are known as hydrocarbons. So hydrocarbons consist only hydrogen and carbon. I can give you some examples, like you have heard of methane, ethane, then propane, ethine, butane, acetylene, etc. Now the next is sources of organic compounds. So what are the sources of organic compounds? So generally organic compounds comes from natural sources, that is from living beings like animals or plants or the petroleum products, because petroleum products are also formed by the decay of animals and plants. So the main sources of organic compounds are the plants, animals or the decay of dead animals and plants, that is petroleum product. So you can see like there are so many acids, formic acid or acetic acid, or there are so many hydrocarbons like methane, ethane. So all of these come from the petroleum product or animals or plants. The next is importance of organic compounds. So organic compounds are very important for us because they are used in our regular diet, like in carbohydrates, proteins, vitamins. All of these are organic compounds. Then they are also used in cloths, in medicine, in fuels, etc. Now the next is the unique nature of carbon atom. As I told you, more than 90% of all the known compounds are organic compounds. So the question comes, why does carbon atom form so many compounds and not other elements? Means other elements do not form that number of compounds as the carbon form. So the question comes, why does it happen? It is because of a unique nature of carbon atom. So what is that unique nature of carbon atom? So in this unique nature we will discuss about three unique properties of carbon atom. So the first is tetravalency. As you know, carbon atom has 4 electrons in its outermost shell. So you can say the carbon atom is tetravalent. Tetravalent means it has 4 electrons in outermost shell. So it can combine with 4 different elements, or you can say it can form 4 single bonds or 2 double bonds or 1 triple bond and 1 single bond with other elements. So other elements as well as carbon atom. So it has tetravalency. Therefore it can form 4 different covalent bonds. So the first is tetravalency. The second is catenation. So the question comes, what is catenation? Catenation is the property of an element due to which its atom can link to each other to form a long chain. Tendency of an atom to form the long chain by self-linking, by linking to each other, is known as catenation. So if carbon atom has this property, means carbon atoms can link to each other and result in the formation of long chains. These different chains may be of different types. For example, it may be a straight chain, it may be a straight chain, or it may be a branched chain, or it may be a ring. So what is a straight chain? In a straight chain, the carbon atoms are attached to each other in a straight line, means the first carbon, then second carbon, then third carbon, and so on. You know that carbon is tetravalent, so it will always form 4 bonds. So inside it can be attached to other atoms. The second is branched chain. So what is the meaning of branched chain? In this chain, in this kind of chain, carbon atoms form branches like this. So suppose this is a straight chain, then inside there are branches, or you can say here we have branches. So this type of carbon chain is known as branch chain. In this, there is not a straight chain, but there are also branches. So such chains are called branch chain. And then comes ring chains or ring structure. So in the rings, the carbon atoms, the first carbon atom of the chain will be attached to the last carbon atom. So suppose this carbon atom will be attached to this carbon atom. So it will form like a ring structure. So therefore, this kind of compounds are called ring chains. So for example, like this, carbon, carbon, then this carbon attached to this carbon, then, so this is a ring structure. So this is how the different kind of compounds can be formed, different types of chains can be formed. So this is due to the catenation. Carbon atom has the highest catenation. The property of catenation is highest in carbon. Silicon also shows some catenation, but catenation is highest in carbon chain. So carbon atoms can link to each other to form long chains, maybe branch chains, maybe straight chains or ring structure. So because of the formation of different kind of chains, it has different compounds. The next is isomerism. So the question comes, what is isomerism? So the isomerism comes from the term isomers. So question comes, what are isomers? So isomers are the compounds having same molecular formula but different physical and chemical properties. So the compounds having same molecular formula but different physical and chemical properties are known as isomers, and the property to form the isomer is known as isomerism. So the compounds of carbon, that is organic compounds, can show the isomerism. They can form different types of isomers. For example, this is carbon, 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 5 carbon atoms. Then hydrogen atoms are attached to each carbon atom. So this is pentane. You can see here, this compound here is pentane. Now, if we see different structure of pentane, so it can be like this: carbon, 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 4 carbon atoms, and 1 carbon atom is attached here. Then, so this compound is called 2-methyl-butane. Now, if you see the formula of this compound, this is C5H12, and the formula of this compound is also C5H12. But you can see these compounds have different structure, so therefore they may have different physical and chemical properties. So this property, this phenomenon is known as isomerism. So you can see the same formula, for the same formula there are 2 different compounds, and there may be more than 2 compounds. So because of that, the carbon atoms, the compounds of carbon atoms are so many in numbers. So because of these properties of carbon, that is tetravalency, catenation and isomerism, carbon can form so many compounds. There are so many other elements which have the property of tetravalency, but all these 3 properties together, carbon atom can form highest number of compounds. So I hope it is clear to you why does carbon atom form so many compounds. The last topic of today, that is organic compounds. So how can we classify organic compounds? So organic compounds can be classified into 2 categories. Organic compounds can be classified into 2 categories. The first The first classification is called aliphatic. Aliphatic organic compounds, and the second comes cyclic compounds. So these aliphatic compounds are also called chain compounds. The next is called cyclic, or these are also called ring compounds. So organic compounds may be classified as aliphatic or chain compounds and ring compounds. So if the compounds have straight chains or branch chain, carbon compounds have straight chains or branch chains, then they are known as chain compounds. But if they have ring chains, means if they form the rings like this or the rings like this, such compounds are called cyclic compounds or ring compounds. Then these aliphatic or chain compounds can be further classified into saturated and unsaturated compounds. So generally saturated and unsaturated words are used. Hydrocarbons. So saturated hydrocarbons are those in which there are only single bonds between carbon atoms, no double or triple bonds. So if there are only single bonds between carbon atoms, remember there are only single bonds between carbon atoms, these compounds are called saturated hydrocarbons. And the hydrocarbons which has double or triple bond, so if there is double or triple bond between the carbon atoms, such compounds are called unsaturated hydrocarbons. Now if we go to ring or cyclic compounds, so ring or cyclic compounds may be classified as alicyclic. So generally alicyclic compounds resemble their chain compounds. So alicyclic compounds resemble their chain compounds. So generally these start with the term cyclo, and then there are aromatic compounds. So what are aromatic compounds? Aromatic compounds are different kind of compounds which consist of double bonds in ring. So let's see some example of saturated hydrocarbons. So for example, methane, ethane. So methane is CH4, carbon atom forms only single bond. Then C2H6, ethane, carbon atom forms only single bonds. Then C3H8, that is propane. So these are few examples of saturated hydrocarbons. Then there are unsaturated hydrocarbons. So unsaturated hydrocarbons, what are the examples of unsaturated hydrocarbons? Ethene, that is C2H4. So in C2H4 there is double bond between carbon atoms. It is like this, C2H4. So this is the unsaturated hydrocarbon. You can see here there is double bond. Or ethyne, you can also say ethyne. In ethyne there is triple bond between two carbon atoms. So the formula of ethyne is C2H2. So these are the examples of unsaturated hydrocarbons. Now what are the examples of alicyclic? So their names are similar to those of aromatic compounds. For example, propane. So in propane we have cyclopropane. Similar to propane we have cyclopropane. However, its formula is different. The formula of propane is C3H8, but the formula of cyclopropane is C3H6. So how does the cyclopropane form? As its name suggests, cyclo, it is a cyclic compound. So there will be a carbon atom, then other carbon atom, then third carbon atom, and the third carbon atom should be attached to the first carbon atom. As you know, you have to remember this point that carbon atom will always form 4 bonds. So 3 carbon atoms are forming one bond to each other. So this is one hydrogen atom, other hydrogen atom. So each carbon atom will also be attached to 2 hydrogen atoms. So this is cyclopropane. Similarly, there may be cyclobutane, cyclopentane, and so on. The next is examples of aromatic compounds. So aromatic compounds, in aromatic compounds, the most important compound is benzene. So what is the formula of benzene? The formula of benzene is C6H6. And what is the structure of benzene? It is like this: one carbon atom, then other, third, then fourth, fifth and sixth. So there is a ring structure in the benzene. You can see here there will be a ring structure in benzene. And now in C6H6 there will be double bond between alternate carbon atoms. You can see the first, second and third. So you can see here each carbon atom is forming a double bond, and now there are 3 bonds already. So each carbon atom will be attached to one hydrogen atom. So each carbon atom is attached to one hydrogen atom. So this is the structure of benzene. So this is how we can classify the organic compounds. Now you can also classify the aromatic compounds further into homocyclic and heterocyclic. However, these heterocyclic compounds are not very important for us in class 10th, but we can further classify these compounds as homocyclic and heterocyclic. So homocyclic means if the chains of the compounds, means the ring of the compounds, if in ring you have no other element other than carbon, so you cannot find any atom other than those of carbon atoms in the ring. So you can see the ring is formed between only carbon atoms. In this compound also, in benzene, the ring is formed only between carbon atoms. So such compounds are called homocyclic. Homo stands for same. Now hetero means different. So heterocyclic compounds are those cyclic compounds in which there is presence of the atoms of some elements other than carbon atoms. So with the carbon atoms there may be some other elements, means the atoms of some other elements other than carbon atoms. So for example, if here we have nitrogen instead of carbon, if we have nitrogen here, so this is a heterocyclic compound. The formula of this compound is C5H5N, and this is called pyridine. So you can see in this compound there is nitrogen in the ring. So such compounds are called heterocyclic compounds. So hope you have understood the classification of organic compounds. If you have any queries, you can ask your questions in comment sections. Thank you very much.